Hello everyone. So today we are going to discuss about some basic elements that you should consider while studying engineering mechanics. Usually whenever we take whatever university, whatever syllabus, in first year engineering we should study a subject called base engineering mechanics. Engineering mechanics is the application of actually plus one physics you have studied earlier, whether in CBSE or state or ICSE. So we are going to refresh some fundamentals of mechanics, then we can enter into our topic. If you know the fundamentals in mechanics very clearly, fundamentally if you know what is a vector and what is a scalar clearly, you can definitely solve almost any question in mechanics. So let us start into what are vector quantities and what are scalar quantities first. It may sound very silly, but it is an elementary concept of physics. You should know whether you deal with a quantity, it is a vector or a scalar. That is very compulsory. So first let us see what is the meaning of a scalar quantity. So first let us see what is called a scalar quantity. We used to know scalar quantity means that quantity only have magnitude. So scalar quantities are quantities only having magnitudes. We know that magnitude fundamentally means a numerical value, that is called a magnitude. Suppose for example we are going to say like mass of a body, it is a scalar quantity. We need to simply say 70 kilogram, 70 kilogram. We don't need anything else. Like in a similar manner we know temperature. We used to say room temperature is, if we say 35 degree, 35 degree, like that we can say. Next we can say about area, similarly volume. All these quantities are fundamentally scalar quantities. Also we know that energy, if you take any type of energy or any type of work, everything falls under the category of a scalar quantity which only have magnitude. But if you move on to vector quantities, let us say you want to study about vector quantities. Vector quantities fundamentally have magnitude. They have magnitude as well as direction. Magnitude and direction both are important for a vector quantity. Common examples, if you try to write, we know first thing coming in our mind will be force. Force is definitely a vector quantity. Similarly we can say moment of force, or we call by the name torque. Moment of force or torque, it is a vector quantity. Next also we can say velocity, which is vector, momentum, which is vector. Likewise so many quantities are there. Momentum. Okay, so this is a fundamental definition we used to study in plus 1 plus 2. Scalar have only magnitude, vector have magnitude and direction. Likewise only we studied. But actually here we should change this perspective a little bit. Then only we can study engineering mechanics clearly. Our perspective is that vectors as well as scalar, it doesn't have to anything deal with the direction idea. Fundamentally we used to say scalar quantities are quantities which obey normal mathematical operations. Scalar quantities are quantities which are obeying normal mathematical operations. For an example, I am going to say one thing. So first I will say the definition. Scalar quantities obeys ordinary rules of algebra. They obey ordinary rules of algebra, which means normal mathematics only they will obey. That is why if sometimes if I am going to keep a block like this, is a block has a mass 2 kilogram, and above that you kept another block. This block has a mass 1 kilogram, and if I ask you what is total mass, you are simply saying total mass is how much? 3 kilogram. We know 1 plus 2 only you done, your answer will come as 3 kilogram. This is the peculiarity of a scalar quantity. It will obey normal mathematics. If I ask you total mass, you add the mass. If I ask you total volume, you add the volume. If I ask you total energy, you add the energy. Total work means you add all the works. Our only operation we are asking, they ask a total value or they ask a net value, you have to simply add them. That only you have to do in a scalar quantity. While dealing with the vector, vector will say something different. Vector quantities obeys vector algebra. So vector quantities obeys vector algebra. Vector algebra is a new kind of mathematics and it is compulsory you have to learn this mathematics, otherwise we cannot study engineering mechanics. So regarding vector algebra, as an introduction, if I am asking you like this, suppose there is a block kept here. In this block you applied a force of 20 Newton. Then you applied a force of 20 Newton. And now I am asking you what is the total force acting on this body. You will say it will be 0 Newton. We are writing it for a long period of time. Why you didn't set the 40? Why you didn't set the 40 Newton? 20 plus 20 equal to 40. Because you performed not a normal mathematics here. Normal mathematics means total value means addition only. You don't have to say anything. But here you subtracted 20 from 20. You took a right as positive, left as negative. Therefore your value comes as 0. So indirectly, without knowing, you applied a mathematics there. That mathematics is called a vector algebra. In a similar manner, if you want a more clear idea, we can think about one case. A body traveled from here to here, it covered 3 meters. A body traveled from here to here, it covered 4 meters. And maybe they will ask you distance. Distance is a scalar quantity. What is the total distance covered? We will write 3 plus 4. That will come as simply 7 meters will be your answer in distance. It is a scalar quantity. That is why we simply add and said it is the total quantity. While if we are going to take a displacement S, displacement is fundamentally you take a starting point, you take an ending point, you connect them by a straight line. That is called your displacement. Since it is a right angular triangle, you will get a displacement is 5 meters. So I can say displacement here is 5 meters and it is a vector quantity. Now my question, first one is logically possible. I give you 3, I give you 4. You add them 3 plus 4, you will get a 7. I give you 3, I give you 4. But now you are giving me an answer 5. How we can make 5 using 3 and 4? You can multiply them, you can divide them, you can add them, you can subtract them. Still you won't get 5. But here your answer is 5. Without knowingly, you applied a special type of mathematics here, and that mathematics is called vector algebra. So you can simply forget about the definition. Scalar quantities have magnitude, vector has a magnitude and direction. It is not like that. Scalar quantities means it will obey normal mathematics. Total value means you simply add each quantity. But vector quantities, if they ask you total value, or in other words in physics we call resultant value. They ask you resultant, what you have to do purposefully is to learn vector algebra and do that resultant by using vector addition. That is your purpose. So now let us study vector algebra so that majority of problems in physics will be going to get vanished. So let us study vector algebra. Vector algebra, there are so many operations are there. Vector addition, vector subtraction, vector multiplication. But most commonly we only need vector addition mostly. So first we will study vector addition, how we can approach it. How will you add two vectors? If you want to add two vectors, fundamentally we have two methods. Our method 1, we call it by the name parallelogram law. So method 1 is parallelogram law, and method 2 is triangle law. You have parallelogram law as well as triangle law. It doesn't matter which law you are choosing, both will give you the same answer. It is like you are doing 3 into 4, you will get a 12, 4 into 3, you will get a 12, like that only. Both will give you same answer. So my personal favorite is parallelogram law. Almost in every book they are using parallelogram law, so we will proceed with that. So how to do a problem using parallelogram law? So let us give a heading, parallelogram law. So parallelogram law. Now let us see how in parallelogram law we are going to find addition. How will you add two vectors using parallelogram law? I am showing the derivation, but in examination if derivation theory coming you can learn, otherwise you can skip that part. So here in derivation, anyway I suggest you to see it. So according to our derivation, you will be having a vector A. Let us say this is your vector A, this is vector A, and you will be having another vector. Let us say this is your vector B. If you want to apply parallelogram law, you have to join tail to tail. We know what is a tail and all. This point is called a head and this point is called a tail. This point is called a head and this point is called a tail. We will join tail to tail. So I am going to take like this and I am joining tail to tail like this. Now you are ready to apply parallelogram law. According to our parallelogram law, what we will do will be, we will be constructing a parallelogram like this. So we will draw vector A, same length like this, vector B, same length like this. We will construct a parallelogram. And the diagonal of this parallelogram starting from the tail joining. From here, if you draw a parallelogram diagonal, this diagonal is called your resultant, which means this diagonal we will represent by R. And this R value will give you vector A plus vector B. Whatever the value you are getting for R, that has to be A plus B. Now itself we can understand how much complicated it is. Actually, if you want to add 5 plus 2, I am literally asking you to draw a parallelogram. Then draw a diagonal, measure that diagonal. The diagonal will give you 5 plus 2 value. So this is the logic of vector addition. Anyway, it will make sense later. So remember, this is the fundamental idea. But by drawing and finding out is a very difficult task. That is why we are having some numerical equation directly. So I am going to show you that. So I am just removing this thing. And directly let us see how we will apply parallelogram law for a derivation. So I am drawing that figure one more time. This is your vector A, and let it be this be our vector B. Vector B, and A and B made an angle theta. So we will construct a parallelogram as I told earlier. This is the parallelogram we are constructing like this. And in this parallelogram we will draw the diagonal. This is the diagonal that will give you A plus B value. We generally represented by resultant R. Okay. Now let us see how we are going to do. First I will extend this vector A like this. This is our vector A. I am extending like this. From topmost point, that is from this point, I am simply dropping a perpendicular like this. A 90-degree perpendicular I am dropping. And what I am going to do is that if this angle they are given as theta, this angle will be also theta. Sides of parallelogram are parallel. Therefore, this angle will also come as theta. That we understood very clearly. And this side is B. Definitely this side is also B. That we know. Now, what I am going to do is that I will take this small right angle triangle. This is a small triangle. For convenience, if you want, we can give them some names and all. So I am going to give now some name like A, B, C, D, E. Likewise, I am giving some names. So here, first in that triangle, so right angle triangle, I am going to take B, E, C. In that triangle, let me take sine theta. If I take sine theta, opposite side we know it will be EC divided by adjacent side, sorry, hypotenuse will come as B. Therefore, I am getting EC is equal to B sine theta. Okay, so I got one result here. EC is equal to B sine theta. Similarly, in the same triangle, I will take cos theta. Cos theta will be equal to adjacent side, that is BE, hypotenuse will be capital B. Therefore, I am getting BE is equal to B cos theta. I got the second result. Okay. Now, next I am going to consider a right angle triangle. My aim is to find this capital R value. In order to find that, I am taking triangle AEC. Here I will show in that triangle AEC. This bigger triangle we are going to take, and R will come as the hypotenuse. That is the required quantity. R will be your A plus B value. So here, if I am applying Pythagoras theorem, I can directly write AC square. AC is the hypotenuse. So AC square is equal to AE square plus EC square. Likewise, I can write. So next step, I can also write AE can be written as AB plus BE square plus EC square. And if you are looking, AC value will be definitely equal to R. So that will come as R square. And AB value is A. And BE value we already find out from here. BE is equal to B cos theta. Therefore, we can put it as B cos theta. And we are squaring plus EC. If you look EC, we already got EC here. EC is B sine theta. So EC value we can put B sine theta, and that will be square. Now let us expand this. If we are expanding, this will come as R square is equal to, this is A plus B whole square, A square plus 2AB cos theta, 2AB plus B square. B square will become B square cos square theta. Okay. And remember, here I have to put capital B. I made a mistake here. This is capital B. So from here I will get this as what? B square sine square theta. And from here we know cos square theta plus sine square theta will become 1. Therefore, resultant R has a value root of A square plus B square plus 2AB cos theta. Okay, so that is the final answer, and which is the most important equation we are studying throughout in physics. Also in engineering it is very important. I want you to remember carefully. R is equal to, which means whenever you need to add two vector, this is your method. Root of a square plus b square plus 2ab cos theta. So remember, whatever answer you are getting from here, that is the numerical value of a plus b. If you add a vector a plus vector b and you take a numerical value, I put a modulus symbol. Only the numerical value you are taking, that will be root of a square plus b square plus 2ab cos theta. Also sometimes they will ask you, this resultant makes how much angle. For that principle, if you want, you can simply mark this angle by a name alpha. Then consider that bigger triangle and you can find a tan alpha. Suppose if you are taking tan alpha, I will wipe off this region and we will take a tan alpha. So tan alpha, opposite side, I am talking about this big triangle. So opposite side is simply EC. Adjacent side is AB, AE. So we can write AB plus BE. Now I am substituting the value. Directly I can write tan alpha is equal to EC. Already we written EC value will be B sin theta. That is your EC value. Divided by AB. A to B it is A. Plus B. B will be B cos theta. That's it. Therefore you got tan alpha value. That is the angle that vector is making with the vector A. So we can say this is direction with respect to vector A, because alpha is marked with respect to A. That is why you are going to write like this. You can remember, if you are marking with respect to A alpha, B will come along with the trigonometry, which means if you have two forces 200 and 240, you want angle with the 200, then 240 will occur in both the trigonometric terms. It will become 240 sin theta and 240 cos theta. Like that only it will come. So we can keep that in mind. Very rarely they will ask, but still there is a possibility they can ask in your examinations and all. So I think everyone understood what is parallelogram law clearly. I will also briefly explain triangle law of vector addition, but remember, triangle law we are not applying anywhere else. Okay. So according to triangle law, what we are going to do is that in triangle law we will be having vector A like this. So I'll give the heading triangle law. That is a triangle law. You are having a vector, let us say vector A. Okay. Now you will be having another vector also, that is your vector B. So vector B, this time they provided like this. This is vector B. And this time what we are going to do is that previously we joined tail to tail, or else you can do head to head also previously. Here what we will do is that the head of one vector is joined with the tail of another vector like this. During this thing you will get two sides. Then what you have to do is that you have to close it and form a triangle like this. Then you have to take arrows in opposite sense. These arrows are actually tracing and going like this. So I can say these arrows are going in anti-clockwise direction. Therefore opposite to that clockwise direction you have to give the vector, and this will be your vector R, and vector R will be vector A plus vector B. That is what going to happen. So here we don't have any formula and anything and else. You just have to remember this is triangle law. Remember, parallelogram law, triangle law, both will give you same answer. But in my lectures and all, I am going to only follow parallelogram law. Whenever you need to add two vectors, we will apply root of a square plus b square plus 2ab cos theta. If you have two forces say f1 and f2, I will write a root of f1 square plus f2 square plus 2 f1 f2 cos theta. Like that only we will find the net force. And things can be easy because every time we cannot apply this bigger formula. So we have some special cases that we will study in our next lecture. After studying special cases, we will do some problems. By that parallelogram law you can understand. Okay, so I hope everyone understood the derivation, everyone understood what is a vector, what is a scalar, and how we are going to apply these equations I will teach in the coming lectures. Okay everyone, thank you.